Welcome. I'm Carol Caprio, an LPC, and you are watching a New Life Counseling podcast where we talk about things that are mental health related. The topic for today is chemicals in your brain that affect your mental health, also called neurotransmitters. I want to share this disclaimer. I'm not a doctor. This is based on my own research. This is a psychoeducational podcast. If you hear anything that interests you, please do your own research or reach out to a functional medicine doctor. As I said, I'm going to talk about what some of the neurotransmitters do, where they come from, and how they can impact your mental health. Let's start with serotonin, often called the feel-good neurotransmitter. Serotonin is involved in regulating mood, anxiety, and happiness. Low levels of serotonin are commonly linked to depression and anxiety. Then we have dopamine. This neurotransmitter is associated with the brain's reward system. It affects motivation and pleasure and feelings of reward. Low levels of dopamine can contribute to feelings of apathy and low motivation, which is common in depression and some other mood disorders. Next, norepinephrine. This chemical plays a role in the alertness and energy. It is also involved in the body's fight or flight. Response can affect mood by helping with focus and attention. Low levels may contribute to feelings of lethargy and low motivation. Next, endorphins. Often referred to as the body's natural painkillers, endorphins are chemicals released during activities like exercise and laughter. They help reduce stress and promote feelings of euphoria or well-being. Then we have GABA. This neurotransmitter helps inhibit brain activity and promotes relaxation. Low GABA levels can be linked to increased anxiety and stress. Then glutamate. It's the main excitatory neurotransmitter in the brain and helps with learning and memory. However, imbalance in glutamate can also affect mood and contribute to mood disorders. And lastly, oxytocin, known as the love hormone. Oxytocin is involved in bonding, empathy, and trust. High oxytocin levels can promote feelings of love, connection, and well-being, while low levels can negatively affect emotional bonding. Now we're going to talk about serotonin. Serotonin is primarily produced in the brain and the intestines, with the majority of it being found in the gut. In the brain, serotonin is produced by neurons, nerve cells, in specific areas of the brain, most notably in the brainstem. Serotonin is then released into various parts of the brain to regulate mood, anxiety, and other functions. In the gut, about 90 to 95% of the body's total serotonin is located in the intestines. It's involved in regulating gut function, like controlling bowel movements or promoting smooth muscle contractions. The remaining serotonin in the body is found in platelets and in the central nervous system. Serotonin is synthesized from an amino acid called tryptophan. Tryptophan, which you can get from foods like turkey, eggs, and nuts, is converted into 5-HTP by the enzyme tryptophan hydroxylase. 5-HTP is then converted into serotonin through the actions of another enzyme called the aromatic L-amino acid decarbolase. Since tryptophan is the precursor to serotonin, factors that affect tryptophan levels like diet and stress can influence serotonin production. So where does tryptophan come from? Tryptophan is the essential amino acid. The body cannot produce it on its own. It must be obtained through diet. So here's where it comes from. Tryptophan is found in a variety of protein-rich foods, and it is an amino acid that makes up the building blocks of proteins. So good dietary sources of tryptophan include poultry, like turkey and chicken, eggs, cheese, fish, nuts and seeds, like pumpkin seeds, sesame seeds, and almonds, tofu and soy products, oats and other whole grains, and dairy products like milk and yogurt. Because tryptophan is found in many protein-rich foods, it's relatively easy to obtain through a balanced diet. So is it used in our body? Once ingested, tryptophan is absorbed in the small intestines and transported to various tissues throughout the body, including the brain. The body then uses tryptophan to synthesize serotonin. If there's enough serotonin, it can be further converted into melatonin to help regulate sleep-wake cycles. So why is it important? Tryptophan is important for serotonin and melatonin production. It competes with other amino acids for transport across the blood-brain barrier. Therefore, the presence of carbohydrates in a meal can help facilitate tryptophan's entry into the brain, as insulin release from carbs helps clear other amino acids from the bloodstream. So, in summary, Tryptophan primarily comes from dietary sources like turkey, eggs, dairy, nuts, and seeds, and it does play a vital role in producing serotonin and melatonin. Now let's look at where dopamine comes from. Dopamine is produced in specific areas of the brain. These areas are part of a larger system involved in reward, motivation, and motor control. Dopamine is synthesized from the amino acid tyrosine, which you get from foods like chicken, beef, eggs, dairy, and soy. Tyrosine is the first converted into L-DOPA by an enzyme called tyrosine hydrolase. L-DOPA is then converted into dopamine by another enzyme called aromatic L-amino acid decarbolase. So where does tyrosine come from? It's an amino acid mostly obtained from the diet. Dietary sources for tyrosine can be directly acquired through food. It's found in protein-rich foods like meat, fish, dairy, eggs, nuts, seeds, and legumes. Next is norepinephrine, also called noradrenaline, and it is produced primarily in a small cluster of nerve cells in the brainstem. It's also made in the adrenal glands, which sit on top of your kidneys. So norepinephrine is synthesized from amino acid tyrosine in the two-step process. Tyrosine is first converted to the L-DOPA, then L-DOPA is converted to dopamine, which is further converted into norepinephrine through an action enzyme called dopamine B hydrolase. Dopamine B hydrolase is primarily found in the non-adrenergic neurons and the adrenal glands. So where do endorphins come from? Endorphins are produced primarily in the pituitary gland and the hypothalamus, which are both located in the brain. The pituitary gland, often called the master gland, is responsible for releasing endorphins in response to pain, stress, or intense physical activity. The hypothalamus also releases endorphins, especially during emotional and physical stress. So how are endorphins made? Endorphins are actually a group of peptides, small proteins, that are derived from larger precursor proteins. When the body experiences stress, pain, or intense physical exertion like exercise, the pituitary gland and the hypothalamus release these endorphins into the bloodstream and the brain. This release helps to alleviate pain and creates feelings of euphoria, often referred to as the runner's high. So they're often released during activities like exercise, laughter, sex, eating spicy foods, or even while listening to music. Now let's talk about GABA. GABA is the main inhibitory neurotransmitter in the brain, meaning it helps to calm down neural activity and promote relaxation. It's produced in the brain, specifically in neurons or nerve cells that are responsible for releasing it. GABA is synthesized in the neurons of the central nervous system. The key region where it plays a significant role include the cortex, the hippocampus, the thalamus, and the amygdala. GABA is synthesized from glutamate. GABA works by binding to GABA receptors on neurons, making the neurons more negatively charged and less likely to fire, which helps to inhibit or calm down the electrical activity in the brain. So key roles for GABA: anxiety regulation. GABA helps reduce anxiety by calming overactive brain regions, particularly in the situation of stress or fear. Sleep and relaxation. GABA promotes restful sleep by inhibiting neural activities and helping the brain wind down. Muscle relaxation. Since GABA is involved in the central nervous system regulation of movement, it can also help in relaxing muscles. And it balances with glutamate. GABA and glutamate work together to balance the excitation, inhibition in the brain, keeping neural activity in check. Now a little bit more about glutamate. Glutamate is the most abundant excitatory neurotransmitter in the brain, meaning it can help activate neurons and play a major role in cognitive function like learning, memory, and overall brain plasticity. Glutamate is derived from the amino acid glutamine, which is found in many of the foods, especially protein-rich foods like meat, dairy, and some plant-based foods like nuts and legumes. Glutamate is primarily produced within the brain. Neurons in various regions of the brain synthesize glutamate to use in synaptic transmissions. Once synthesized, glutamate is released by neurons into the synapse where a signal needs to be transmitted. Glutamate and GABA work together to maintain a balance in the brain. While glutamate excites neurons, GABA helps calm down excessive activity and prevents overstimulation. Proper balance between glutamate and GABA is crucial in healthy brain function. So in summary, Glutamate is primarily produced by glutamine in the brain and plays a vital role in promoting neuron activity, learning, and memory process. And the last one we're going to talk about today is oxytocin. Oxytocin is a hormone and neurotransmitter that plays a crucial role in social bonding and emotional regulation and reproductive function. The majority of oxytocin is produced in the hypothalamus. After its synthesis, it is transported to the posterior pituitary gland, where it's stored and released into the bloodstream when needed. When triggered by certain stimuli, such as childbirth, breastfeeding, bonding activities like touch and social interaction, oxytocin is released from the primary gland in the bloodstream. Oxytocin also has important effects within the brain, particularly in the areas related to emotional processing, such as the amygdala, which helps process emotions like fear, and the prefrontal cortex, involved in decision-making and social behavior. So again, in summary, it's the widespread effects on reproduction, emotional bonding, social interaction, and overall well-being. So again, why should you care? Well, here's a list of the medical diagnoses connected to these neurotransmitters: anxiety, depression, ADHD, chronic fatigue, addiction, seizures, Alzheimer's, insomnia, Parkinson's, and disruptions in mood and cognition. So if you're currently dealing with or are concerned about these conditions, make sure you're doing your part. Make sure you're taking care of your body and your brain. So thanks for listening today. Please go to my website, www.newlifecounselingdfw.com, to find links to other podcasts as well as additional resources, including books and links to supporting materials. If you enjoyed this podcast, please subscribe, leave a review, share it with your friends, and as always, remember to take care of your mind and your body.